Good morning, students. Now, today we will discuss minimization technique. That is nothing but the K-map technique. Here, there are three types of K-map simplification techniques, such as two-variable K-map, three-variable K-map, or four-variable K-map, depending on the input variables which are used to represent the given equation. Suppose variables or alphabets A and B, these are used to represent a given Boolean expression. Then we can simplify this particular expression with the help of two-variable K-map. Like that, three-variable and four-variable K-maps are used to simplify the Boolean expressions. As the limitations of algebraic simplification are nothing but there is no easy way to tell whether the simplified expression is in its simplest form or it can be simplified further. Means we cannot say like this is the last or final simplified step by using the algebraic simplification method. This particular problem can be overcome by using the K-map method as well as by using Quine-McCluskey method. K-map method is used up to two variable, three variable, or four variable simplifications. If number of variables increases, then K-map simplification becomes complicated or complex one. That's why instead of using K-map simplification method, Quine-McCluskey methods are easy. Now, let us start with the K-map simplification methods. Basically, K-map technique or this particular method is derived by the scientist Karnoff, and from his name, the method is labeled as a K-map simplification technique. This particular technique is a graphical technique which is used to simplify the given Boolean expressions. The number of cells required in K-map, these are depends on the number of variables which are used to represent the Boolean expression. For two variable Boolean expression, the number of cells required in K-map are 2 raised to 2, that is nothing but 4. Because the digital systems, two notations, that is logic 0 and logic 1 are used. That's why base is used as a 2. For two variable 2 to the power 2, the answer is 4. Means K-map is represented by using 4 cells. Similarly, for three variable K-map 2 raised to 3, answer is 8. 8 cells are used. And also for four variable K-map 2 raised to 4, 16 cells are required to represent given four variable Boolean expression. Here, K-map is a function which is realized by using basic logic gates as AND gate and OR gates. The cost of realizing the function is directly related to the number of logic gates and gate inputs which are used. The K-map technique is developed that lead directly to minimum cost two-level circuits which are composed of AND gate and OR gates. An expression consisting of sum of product terms, that is SOP, corresponds directly to a two-level circuit which is composed of a group of AND gates feeding a single OR gate. Similarly, the product of sums, that is POS expressions, corresponds to a two-level circuit composed of OR gates feeding a single AND gate. Therefore, to find minimum cost two-level and OR gate circuits, we must find minimum expressions in SOP, and POS forms. Now, let us discuss the basic representations of K-map for 2, 3, and 4 variables. Here, vertical representations used. We can follow horizontal representations as well. Here, vertical representation is implemented for 2 variable, 3 variable, and 4 variables. Now let us start from 2 variable Boolean expression or 2 variable K-map. The 2 variables are labeled as variable A and B. For 2 variable 2 raised to 2, 4 cells are required. The K-map is represented by using 4 cells, and these 4 cells are labeled by using decimal numbers as well as by using digital logic. As on row 0 and 1 is indicated for A as well as for B, 0 and 1, these are represented. That's why first cell, or we can say 0th cell, is represented by A0, B0, that is 0, 0. Second cell is represented by A1, B0, that is 1, 0. Next cell is represented by A0, B1, that is 0, 1. And fourth cell is represented as A1, B1. That's why we can vertically compare these cells as decimal numbers vertically. In first column 0, 1, second column 2, 3, 0, 1, 2, 3. We can mark or we can fix the places for decimal numbers like that by giving priority to the alphabets starting from A. Here A and B, these are indicated. That's why priority is given to the alphabet A, because vertical representation is used. In horizontal representations, priority is given to the horizontal or row wise. That's why here the bits or numbers are represented vertically as 0, 1 in first column. For second column 2, 3. 0, 1, 2, 3. These are the places or cell values for 2 variable K-map. Similarly, representations or binary notations as well as decimal notations for 3 variable K-maps are given as A, B, C. These are the 3 variables. 2 to the power 3. 2 raised to 3 is equal to 8. That's why 8 cells or 8 cells in K-map are represented, and these cells are marked vertically as in first column 0, 1, 3, 2, or we can call as 0, 1 in last row 2, 3. This particular arrangement you have to keep in mind. Instead of in sequence 0, 1, 2, 3, these cells are marked like 0, 1, 3, 2 in first column. Similarly, in second column, remaining numbers 4, 5, 7, 6. Instead of 4, 5, 6, 7, these are marked as 4, 5, 7, 6. That's why use the normal practice while representing the cells as 0, 1, 3, 2, 4, 5, 7, 6. Means these 2 columns are reserved or marked for 8 cells or 8 decimal numbers like 0, 1, 3, 2, 4, 5, 7, 6. This is 3 variable K-map. Now, last one is the 4 variable K-map. 4 variables are used as A, B, C, D. That's why 2 raised to 4, answer is 16. There are 4 columns and 4 rows. Let us check in first column as 0, 1, 3, 2. Second column 4, 5, 7, 6. Third column, skip the third column. Now last column 8, 9, 11, 10. And then third column 12, 13, 15, 14. These notations are the standard notations and we have to follow the same notations instead of going in a number sequence. These small changes you have to keep in the mind like that 0, 1, 3, 2, 4, 5, 7, 6. In the last column 8, 9, 11, 10. And in third column 12, 13, 15, 14. This is the representation for 2 variable, 3 variable and 4 variable K-maps. Now, in summary, we can say to represent a given SOP expression, given Boolean SOP expression, enter a 1 on the K-map for each fundamental product that produces one output. Means SOP is nothing but sum of product terms. For example, let us consider y is equal to AB plus AC plus AB bar. In this expression, there are three terms as AB, AC, and AB bar. For these terms, output should be 1. That's why for cell AB, the cell which is reserved for AB, we have to mark that particular cell by logic 1 or by entering the 1. In this particular expression, A bar, B bar is missing. For that particular cell or for that particular term, we have to enter 0. In given Boolean expression, those product terms are present. We have to mark those cells by logic 1. And for missing terms, we have to mark these cells by logic 0. This is the first rule to indicate or to represent given SOP expression in the K-map. Now, second criteria or second rule after representation of the expression in the K-map, second one is the grouping. This is the main task which is used to simplify the K-map. We have to encircle the number of ones which are represented in the step 1 by using different combinations of octets, means 8 ones. We can make the group of 8 ones, 8 successive ones. We can group these ones as a octet, or chords by making group of 4 ones, and pairs by making group of 2 ones. But you have to remember to roll and overlap to get the largest groups possible. Means while making the group, the priority should be given to the highest number. For example, in octet, chord, and pairs, octet is the highest group or which contains more number of ones. That's why while simplifying the K-maps, first, depending on the size of K-map, we have to assign the priority. For example, in a 2 variable K-map, 4 cells are used. That's why we can make the maximum group of 4 ones. That is called as the chord. Because in this K-map, only 4 cells are there and highest possibility is all ones. That's why we can make maximum group of 4 ones and it is defined as the chord. And second priority below the chord is the pair. We can make group of 2 ones in a row or in a column. This is the simple rule you have to keep in mind, instead of making groups diagonally, we have to make the groups either in a row, horizontal manner, or in a column, in a vertical manner. For two variable K map, we have only two choices: chords, pairs. And if chord and pair is not possible, then by default, we have to make the group of single ones. Means chords, pairs, and ones, single ones, are possible combination for two variable K map. Similarly, for three variable K map, maximum cells present in the three variable K map are 8 cells. That's why we can follow the sequence by assigning the priorities as octet, chord, pair, and single ones. And for 4 variable K map, the maximum cells in the K map are 2 raised to 4, that is 16. That's why here priorities are assigned for 16 ones, octet, chord, pair, and then single one. Means maximum grouping or groups are possible for 4 variable K map, but keep in mind groups should be in row or in column. Diagonal grouping is not possible. Okay. Then third one, if any isolated ones remain, we have to encircle this single one, that is by making the group of single one. Now next one is the eliminate any redundant group. Only required groups are valid. If any additional or unnecessarily group is made, this group is called as the redundant group. Then finally, from the grouping, we can write the Boolean expressions for that groups, encircled groups. This is the last step in the K-map simplification. See here the meaning of redundant group as shown in the 4 variable K map. There are total 5 groups. 4 groups are of pairs and last group is of chord, that is 4 1. There are 2 horizontal pairs, 2 vertical pairs, and at the center chord group is prepared. But that particular chord group is called as the redundant group because from the chord each one is used or it is engaged in adjacent groups either in horizontal pair or in vertical pair. That's why this chord is the redundant group. Unnecessarily, this particular group adds or increase the number of product terms in the final K-map expression. That's why by avoiding this redundant group, we can write in output as an expression of y is equal to 4 product terms for 4 pairs. Instead of using 5 product terms, 4 product terms are sufficient. Means we have to give the priority to the highest number of ones, but as well we have to check the adjacent ones also. If in this given expression, if chord group of chord is done initially, then 4 ones are remaining at the side of chord, then second choice we have to give to the pair instead of going for the single one pairing, single one group. That's why this chord group is the redundant group. Here possibilities are only of 4 pairs and chord group is the redundant group. I hope the concept of redundant group is now clear to you. Okay. Then in the next lecture, we will discuss on the next simplification technique, that is Quinn McCluskey method.